Hello friends, now today we are doing problem number 188 of Leetcode, best time to buy and sell stock file 4. So I will put the question link in description. Now go to the question. So you are given an array of prices, and for the ith day you can sell that stock, but before selling you have to buy that. So this is the constraint. Most of you have got the question. So let's jump on to the problem. So firstly we will discuss one approach, and then we will try to optimize it to a better approach. So as you can see, it's a typical dynamic programming problem. So here what we will achieve is that we will make track of the transaction. So if they are a kth transaction, we will start from 0 transaction, 1 transaction, and therefore, and in each transaction we try to get the maximum possibility way. So either you have to sell that stock or you don't have to sell. So we have two choices. So according to the basic DP problem we will solve, and the complexity we will see later. So let's jump into the problem, and for the optimal parts please use the timestamp and go to the forward part, for that will be more optimized. So let's start the brute force or the simple dynamic programming approach. So first we will create a DP table. So in DP table we have a k number of transactions. Okay, then we will have n is the size of the prices, right? Okay, then we will first declare the value of n. So this is the size of the price. Now we will make all the value of the DP table to 0, right? Fine. Now we will write the transaction what we will have to do. So we will just do starting just like a normal dynamic problem. So we will start from one transaction and we go up to the k transaction, right? Then after that we start from the position from where we can do. So we can start from g equal to 1, right? Then so this at this index we have to sell the product, right? So we will just write that we have to sell that j product, and before selling it is given that you have to buy, then you can sell. So here in note you can read that. So you have to buy first. So let's iterate. Let's make the other loop. So where we will start from j minus 1, and j should be greater than L should be greater than equal to 0. We will decrement that, right? Also firstly we know that you can take that or not. You have to take decision. So let's suppose that we first initialize the value that at that transaction, at the ith transaction, and we have the jth place. We can just ignore that part. So we will go to the I minus 1 transaction, and from there we can use that. So we can just do that part, but we have to maximize it. So I can just use that maximum, whether to take that maximum value, or if not, then what you will do, you will take the j minus 1, similarly I minus 1 transaction, and before just I place, right? And you have to sell that offset. Also you have to subtract, but where you have to subtract? So if you choose the ls part, so ls will come here, right? The ls transaction, and you will have to subtract that ls price. At the ls price you will have to subtract and sell at the js price. So that is the thing I am trying to write. Okay, so here it will be l, right? Okay, let me indent it. Yeah. So that's it, I think. Now we will simply return. So what will be the value? So what should we return? So we will, to the kth transaction we are going, and up to the jth part, that is n minus 1, right? So I think so it should be right. One thing here, that j is 1 and j is less than n, it is right. And if l equal to 0, then it will go to the negative part, right? So we will have to take care of that, right? Yeah. So what can you do is that we have taken the jth value and j less than n. So we can make one-way indexing, so it will be much easier for us, right? Yeah. So let's do that, I think. So j minus 1, and yeah. So make it 2. Okay, so we have j minus 1, right? And we will find here also j minus 1. So it should be n now, right? So it should be n. Now I think so it will be fine. Let's run, check. It is giving wrong. So let's try to print it where it will be wrong, so it will make much easier for us. Or we can see where it is wrong. So I have taken size k transaction, it is 0, I 1, I plus plus, j less than n. And if j is at 2, then you have to take from one index, right? Yeah. So I minus 1 transaction, j is greater than 0, I j minus 1, fine. And so if you take L, so L minus 1 is fine, plus L minus 1, I think so it's right. Let's check whether it is wrong. So I 0, I less than 23, and plus able to go to the I minus 1 transaction, right? So what is that we are I minus 1 transaction, so don't try to go to the I minus 1 transaction, right? Just take that and this value. I think it will work. It should. Yeah, it is working. Let's try to submit it. I think so. It's submitted, so it is successfully. So let's look at the complexity. So we have taking the transaction wise one by one and looping from the index j, and then searching for the which of the minimum value which we will buy, and then sell at the maximum at that jth position. So overall complexity will be order of n cube. So now there will be a little bit of trick, so how to get the optimized part. So let's discuss here, so it will be much easier for us to understand. Okay, so if we look at here this part, so let's copy that part. So right, so take that one. So here we can see that we are using, this is the same, that whether you don't have to take those, just take that maximum value. And here we can see that we are using the previous transaction, or so there is one thing that you don't have to take that decision, that transaction to your account. So just take the previous decision I minus 1 and then at the L minus 1, right? Yeah, what is L here? We here it is 0, L is less than J and greater than 0, right? So here we are seeing that we are just taking the maximum value of previous two. So what can we do is that we can declare a previous diff type of thing, or so let's first try to understand, so how can we use that. So if you look at that part, focus on that part, what are the things that is common in the jth position. So you can see that the cell is common in all three, so we can just put the back into the put out of the maximum position, and the maximum will be dp of I minus 1. Let's put the L minus 1 here also, and minus of prices, right? Yeah, so we are here. One thing also to understand, that we are starting from Lj minus less than j, so we are just taking the previous value. So why not just change to L to j, right? So now we have eliminated one extra row. So let's try to implement that part. Okay, yeah, so that part will remain same. Yeah, this part will remain same. Here we can use that part. Okay, so here you can also use that at the previous transaction we are using, so we can use here declare. Okay, so let's declare the trade difference is equal to minimum, right? Now let's don't delete it, let's make a comment out, much easier to understand. So what we will do is that we will try to make that part maximum, right? Here we are trying to make it maximum, so just take that maximum of trade diff, whether to take that or to minimum part, that is j minus 1, right? So this one plus, and what we are doing is that we are minusing. So here we also have to make minus of prices, and it should be j minus 1 because in place of l minus 1 we are implementing j minus 1, right? And what we can do is dp of ij is equal to maximum of p of I minus 1 j, right? I think you will understand that. Okay, yeah. So, or you can take the previous transaction and up to the j, behind the j we can use that j minus 1. So what we can use is that's the primitive function. So this one minus this one plus, right? Because we are selling that j solution. Yeah, this is the part. Yes, and j should be 1, right? And it should be less than 1. Here we have to, so I am little bit confused about this part, that it should be I minus 1 or I minus 1 or j minus 1, right? So um, um, we can take at that transaction I transaction, but you don't have to take that one. So I think it will be okay. And but here we are decrementing the value, so make it I minus 1. Okay, let's run and check that whether it is showing right. It's showing correct for this, and also there are some edge cases, so if we have to also make count of that. So if c equal to 0 or n equal to 0, simply return 0. Let's submit. Hope for that it will work. Yeah, it will work. So I hope you understand that whether we are trying to what we are trying to do that here. Some of have you doubt that why we are replacing I with j, because one thing is that but we are l is always less than j. Sorry, you will be confused about how the l is vanished. So if you can show, we can here say see that the l is starting from back side of the j. So we are, and also we are taking the maximum value. So why not replace l with j, and we will just track of the previous values of the j, and where j minus 1 is actually l here, right? So we are just using that fact. So that's it for today. Next day we will start with some other problems, or it will be on mainly on dp hard problems. So thank you, bye. And also please like and subscribe if you like the content. Yeah, and thank you for your support. Bye.